In the last video, we studied about the force experienced by a charge when it is moving in a magnetic field. But we just introduced here the magnitude of force, not the direction of the force. Then what should be the direction of force experienced by a charged particle? We will see in today's class. So to understand that, you need to know the first year topic, that is cross product. It is also called as vector product. You must know it. Without having the knowledge of that, you will not understand the force direction. So the direction of force. Before that, you must know what is A cross B. A cross B is equal to magnitude of A, magnitude of B, sine theta, right? Multiplied by unit vector. Now, these are the two vectors. A and B are the two vectors. So that is showed in the diagram here. So this is A and this is B. One more vector, which is B. That is started from somewhere here. It is started. So these are the two vectors. The angle between these two vectors is theta. Then what is the direction of A cross B? The direction of A cross B is found by curling your fingers of right hand. Curling your fingers of right hand from A towards B. So where is A vector? The vector A is somewhere here. And curl your finger, start from here and towards B. If you curl your finger like this, and where the thumb points, the thumb, if you stretch it, it always points in this direction, and that is the direction of A cross B. That is the direction of A cross B. And here one more diagram is there. So A cross B they have considered. So to find out the direction of A cross B, you have to curl your finger from A towards B like this. Then where the thumb points in the upward direction. That is the direction of A cross B you are going to get. And that A cross B you see, that is perpendicular to both A and B. It should be perpendicular to both A and B. Suppose if you consider minus with a negative sign, you multiply minus with this, then according to the rule of cross product, if you write minus, you can interchange that. This is A cross B, it becomes minus C is equal to B cross A. This is the rule of the cross product. It doesn't obey commutative law. Then you have to change or curl the finger from B towards A now, right? B towards A. So curl your finger from B towards A. So where your thumb points, right? Curling finger from B towards A, thumb points in the downward direction. So if it is positive charge, the thumb is pointing upward. If it is negative charge, the thumb is pointing downward. So it is not obeying commutative law. Here it is given. You studied it in the first year also. You studied it already. So this is the right hand rule for the cross product. Remember this for studying almost this entire chapter. So this is important. Wherever you just see this kind of relation, A cross B or anything, it may be V cross B or it may be L cross B, anything. If you are observing what to do there, you have to curl your finger from L vector to the B vector. Remember, then where the thumb points, that thumb points indicates the direction of this quantity, cross product quantity. So now you have a knowledge of cross product. So let us now study about the charge. Apply it for the charge in motion experiences a force. So according to this right hand rule, the direction of F on a positively charged particle will be perpendicular to the plane and upwards. So F is equal to Q into V cross B is the formula of the force experienced by a charge, right? To see this, I made one PPT over here. We will see that it is already opened. Okay, somewhere here it is there. Okay. Okay, now see, this is a plane and this is the direction of magnetic field. Already the magnetic field is applied. Now you know how to apply the magnetic field, right? Now there is a charge. This is a plus Q charge. This plus Q charge is moving in this particular direction. You're observing that is the direction of V. So magnetic field is here and velocity is in this direction. Charge is moving in this direction. Now I want to calculate the direction of force. In which direction it experiences a force. This charge experiences a force. As a result, it moves in that particular direction. So to find out that, we need a right hand rule, right? Cross product rule. So you have to curl your finger from V towards B. If you curl your finger from V towards B like this, you have to curl. Then where the thumb points, you see the thumb points in a direction upwards. So thumb is pointing in the direction upward. So there only the V cross B is there. So V cross B is also acting in the upward direction. As a result, the force is also acting on a charge in the upward direction. So when a charge start moving in this particular direction, it start pulling it up because it is experiencing a force upward. If it is positive, so it is purely positive charge, then only it experiences a force upward. But if it is negative charge, it definitely experiences a force downward like this. And for the negative charge we will see. So again I considered a plane. There is a magnetic field applied in the same direction as that of before. Now I considered a negative charge. This negative charge is moving in the same direction. So this is the direction of velocity. Now, since it is negative, you have to multiply negative. Therefore, the force experienced by negative charge is downward. Because you have to curl now your fingers from B to V. Because it is negative charge. B to V, you have to curl your finger. Then thumb points in the downward direction. Okay, this is about the direction of force, but what it is showing I here. This I means the current. If the plus charge is moving in this direction, the current is also in the same direction. But if negative charge is moving in this direction, but current is always opposite to that. That means negative charge is moving in this direction means electrons are moving. If all the electrons are moving in this direction, the current should be taken in the opposite direction. That is the conventional current. That is why here, if it is negative charge, the current is shown in the opposite direction.